So, but this prediction is based on a dummy variable to do the forecasting, right? And we have another way to do that. Is called decomposition method, right? Decomposition method is a little bit complex here. We have several steps, but it just follow the steps one by one, right? One by one. First, calculate CMA, then calculate seasonal ratio, which is observation divided by CMA, and the average ratio, and we want to calculate seasonal index, right? Decentralize the data, find the equation trend, right? Forecasting new trend line, and multiply the trend forecasting by appropriate seasonal index, right? So this is the whole steps. Let's go back to our data here. Our data here. So we have this regression. Let's make a copy of this sheet. Move or copy and check the create a copy to here. Right. Now we do here, do the same here. We don't need those regressions in here. We don't need this prediction here. So we've already created the order, right? The entire number of months here. We also created dummy variable here. And here we want to CMA, we centralize the moving average, right? For the year. If for the year we want to start with the July, right? Start with the July. Because July is in the middle of the year, so we don't have enough size for the June, but we have for July, right? We want, for example, think about it. We are at the middle of the July. We want to go to previous 6 months, right? Which is the January the 15th, right? So how we calculate that is we use the January right times 0.5, right? Only half months here plus 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 plus. And we want another half of the next year, January from the next year, times 0.5, right? The first January and last January, we have 0.5. Others are the whole months, right? That's the average for the whole year, around, right? Around. That is called centralized. The previous half year and the after half year. That's a sum. We want to divide that by 12. Right? And we drag it down. Remember, we cannot do for the last few, right? So stop at the Q. Stop at Q. Okay. So this is centralized moving average. Okay. So after that, we want to calculate the seasonal ratio, right? Seasonal ratio is called it's just observation divided by CMA, right? That one is easy to calculate. The seasonal ratio is called the actual value divided by the CMA. Okay, double click. Check the last one. We don't want those. Okay. The third step would be the seasonal index, right? We want to calculate this is the difference between the months to the entire year, right? And we want to calculate on average what is the July, right? During the whole period, what is July to the whole year, right? Just seasonal index, seasonal index, which is average, average year, average year. The range would be the month, right? This is month, monthly, and the criteria would be the month number for this row, right? The month number for this row, and sum is Q. And we only need 12. We only need 12 entries, right? Only need 12 entries. We'll see from this July to this July, they would be the same. They would be the same, right? And then you can choose either we start from January to the December. That makes sense easier. To December, right? 12. Also 12. Right? January to December. Okay, so but the problem is if we sum them together, you can see from here, the sum is a little bit higher than 12, right? We want it to be normalized. We want that on average everyone is 1, which means we add them together becomes to 12. So we want to do a normalization. For this one it's okay because the sum is 12, but sometimes it's too big, right? We want it close to 1 for every because it's a ratio, right? So what we want to do is this 1 times 12 divided by sum of this 12 index, and we want it absolute because we don't want to change, right? So you will see it's almost the same, but the only problem is when we sum them together, it becomes 12. Right? Okay. So, and then we know the season, right? This one means on average, the general would be 46% higher than the average of the year, right? So we want to calculate the seasonalized, price, right? Price. So for January, right? For January, for example, this one is 16.5, but on average higher, 46 higher than the regular price. So we divide it by 1.46, right? So this one is equal to this one divided by that one, right? But the issue is that if you do this way, when you drag it down, it will become problem, right? The later won't have the denominator to do, right? So to solve that problem, we want to do the price divided by the index, right? We want to find out, right? This start from January. So we want the first one, the order, the month, right? The month. Month 1 is the first one, month 12 is the last one, and come to here, there's another one, right? We come back again, right? So this is the index, okay? And freeze this reference, because we only have 12 cells. So this is the way you calculate the decentralized price. Right? It's better to start from January, right? If you don't start from January here, the index won't work. Only if you start from January to December, right? In terms of the seasonal index and normalized index, start from where doesn't matter, but it is easier for you to use index here if you start from January. Another way is to use VLOOKUP, right? You can use VLOOKUP too if you don't start from January. Then we have the decentralized data, right? We can calculate the trend, the trend. Decentralized trend, right? This one only needs because this one contains all the information from the seasonal index and without seasonal index. So we just calculate the trend. So no y should be this decentralized price. Okay. And no x would be the order. Right? The order. And new x is the just this one, right? And this one gave us the seasonalized trend prediction. Right? You can see it's almost the same number because we removed out the season factors here. But in the final one, we want to add it back, add the seasonal back. So this is the final forecasting. Forecasting would be we just multiply back the factors here. So this one times index is and the mouse. Okay. Yep. This is the forecasting we have. Forecasting. Remember, you can use the regression model, requires the data analysis tool to replace this trend function here. That's the same as what we did before. Okay. So this one.